In this section, we look at actually two sections, 2.3 and 2.4, that we do at the same time, and we look at two ways of writing down the equation of our line. Now we've seen the form y equals mx plus b for the equation of a line, and we know that the coefficient in front of x is the slope, and the b is the y coordinate of the y-intercept. So the y-intercept is 0b. So this form that we have here, this is called the slope intercept form. That's because if we're given the slope and the y-intercept, we can easily write down the equation of our line. So look at the following example. We're given the slope is -2 and the y-intercept is 0,5. So the equation of our line is the slope times x plus the b, the y coordinate of our y-intercept, right? So this is m, this is 0b. So there's no work to do here in order to write down the equation of our line. Here's another example. We're given this line in the plane, and we're asked to find the slope and the y coordinate. Now, to get the value of the slope, I need 2 points in order to obtain the rise and the run and take the ratio in order and get the slope. So this point here is the point 0,3, and this point is the point 3,1. So the slope, which is delta y over delta x, which is y2 minus y1 over x2 minus x1, is, I prefer always to choose for x2 the largest x value. This way I have a positive delta x at the bottom. And for y2, well, y2 is the y coordinate goes with the x coordinate 3, so that's 1 minus 0, like that. So that gives me 1/3. And feels like I did something wrong here, because I've got a slope that's positive. I should be getting something negative since it goes down. And that's because I don't know why I replaced y1 by 0. It's actually 3. So this turns out to be -2/3. That's better. So it's a negative slope. And notice that it works well with this triangle. If we go forward by 2, we go down. If we go forward by 3, we go down by 2. So rise over run, well, it's a rise of -2 and a run of 3, so -2/3. Perfect. And then find the we want to find the y coordinate of the I wrote y coordinate. It's not the y coordinate. I want to find the y-intercept. Okay, so the y-intercept is 0b, which is in this case 0,3. Okay, so that was pretty easy. And from this, I could easily recover the equation of the slope. So maybe find the equation of the slope of the line. Well, it's y equals m x plus b. That's the equation of the line in slope intercept form. But there's another form that we like a lot as well, and it's very important in calculus. So often in calculus, we're given a point that belongs to the line and the slope of that line, and we want to recover the equation of that line. So how do we do this? So I'll give you an example. Suppose the slope is 3/5, and the line, it passes through the point 3 minus 4. Now this point is, its value is fixed, right? So I'll call that y1, x1, y1. Okay, so its values are fixed. Okay, and what I'd like to have is an equation, okay, involving x and y that could be any other, the coordinates of any other point on my line. So a line, slope 3/5, okay, the 3 minus 4, 3 minus 4, first of all, 3 minus 4, we're down here, okay. That's my point, slope is 3/5, so we go forward by 5, go up by 3, so something like that, okay. So that's what my line roughly represents, is, that's how I can roughly represent my line. And so this is 3 minus 4 right there. Now suppose I have another point, okay, xy on the line. So I want to find an equation that relates x to y or y to x. Okay. What do I know about these 2 points? Well, I know that if I look at the rise over the run, that's always constant for a line, right? So that's what our m represents. Okay, so the slope, okay, is actually rise over run, and that's the same value no matter what points I take. So in particular, if I take my point, my unknown point xy, and my known point 3 minus 4, if I calculate the run, well, let me do this, x minus 3, and let me calculate the rise, y minus 4. That's fixed, right? So that doesn't vary in terms of the point that I choose. That's always the same number, right? Because it's always a triangle. The triangles are always similar. So if I would have chosen a point here, rise over run's the same. If I would have chosen a point here, rise over run's still the same, because these triangles are proportional. So the slope, no matter what, is 3/5. Okay, let's look at that more closely. So what do I have? I have y minus y4 over x minus 3 is equal to 3/5. And let's solve that for y now. Okay, so y minus 4 is 3/5 times x minus 3, right? I multiply by x minus 3 on both sides. And finally, I will subtract 4 to get rid of the minus 4. So I get minus 4 plus 3/5 x minus 3. So if you're a bit confused about y minus 4, you can always replace it here by y plus 4. Do the same here. And you do see that on the other side becomes minus 4. Now let's look at the numbers we get here. So this is actually the equation of our line, but it's in a different form than mx plus b, okay? But where's the minus 4 coming from? Hey, that's the y coordinate of our given point. 3/5, that's our slope. And what's 3? That's the x coordinate of our given point. So actually, this is the general form if I have a point x1, y1 that passes through that point that belongs to my line, and a slope m. So this is called the point slope form. Let's take a look at that formula again using another example. So suppose my slope, the slope of my line is minus 1/2, and a point on my line is 2, 1. Okay? The equation of my line is essentially y is equal to the y coordinate of my point. So that's y1, so this, as in this is x1, y1, plus the slope times x minus the x coordinate of my line, so of my point. So this is going to be 1 minus 1/2 x minus 2, and that's our line in point slope form. Sometimes, by the way, we also like to write it like this: y minus y1 equals m times x minus x1. So that's also possible. So both here are what we would call point slope form, because as you can see here in this example that I just did, I had to do no work at all, no computation in order to get the equation of my line given my slope and my point. So I can always write it like that too, like I said, y minus 1, 1 equals the slope times x minus x1. So both are possible. Okay. If I want to change this to a slope intercept form, so in the form mx plus b, so y equals mx plus b, what do I need to do? I'm going to expand the expression above. If I expand it, it becomes 1 minus a half of x plus 1. So it becomes 2, or maybe I should write it like that, minus a half of x, which is plus 2. So what I get from this is that my slope is minus a half. I knew that already. But I get that the y-intercept is 0, 2. So now the equation of my line, after doing this, so this is in slope intercept form. Here this is in point. So both of these point slope form. Okay. Here's another example. I have a line that passes through 2 points, and I want to find the equation of that line. Okay, how do I do this? So find the equation of the line passing through the 2 points. So how can I do this? Well, first of all, I need the slope. What's my slope? It's delta y over delta x. So what's the largest x value of 5? Okay, so I'm going to choose the first point as my y2 x2 y2. So 5 minus 3, and I'm going to subtract minus 4 and 7, like that. So I get minus 11 over 2. Oh, I did it the other way around. I did delta x over delta y. Let me correct this. Okay, so hang on. The largest x is actually 7 minus 4. And I need to subtract 3 and 5. Okay, that's better. Sorry about that. So that's minus 2 over 11. That's my slope. And now I have my slope. I don't have my y-intercept, right? So no need to calculate it. It's okay. I've got a point. So as soon as I've got a point and a slope, I can use the point slope form. So the equation is, so how did that go? Is a y minus the y coordinate of the point that I choose is equal to the slope times x minus the x coordinate. So let's clean this up a bit. Get x plus 4, like that. Okay, so that's a possible answer. Here's another possible answer. You can send the 5 on the other side. Okay, but notice that I didn't have to do any sort of work in order to get this equation. Okay, or here's another possibility. You know, I chose the first point as my point. I could also choose the second point. I could choose m as well. Keep m is still minus 2 over 11, but my point, I could also use 7/3. So how would my equation look like? It will look like y minus the y coordinate is equal to the slope times x minus the x coordinate. And after sending the 3 on the other side, I would get this. So both are actually good. I could give that as my answer. I could give that. And then you may wonder, well, are these equal? are these equal? Because I mean, I can't have this two different equations for the same object, right? Well, let's take a look. If I expand them, I'm going to put them in the form mx plus b. They should be the same. So if I expand, what do I get? I get 5 minus 2 over 11 minus 8 over 11. 5 is 55 over 11 minus 8. That's 47 over 11. Missing an x here. Minus 2 over 11x. In the form mx plus b, it's this plus 47 over 11. So 47 over 11 is the y-coordinate of the y-intercept. If I do the same thing here, I get minus 2 over 11x. So as you can see, it's the same coefficient in front of x. Plus, what happened there? Plus 7. Not plus 7, plus 14 over 11. Sorry. Plus 14 over 11. Now, what's 3? 3 is 33 over 11, plus 14 over 11. 33 plus 14, that's 47 over 11. So yes, it is exactly the same equation, right? After expanding, so the form mx plus b is unique. The form, the point normal form, point slope form, sorry, that form is not unique because it, well, the way it, at least it initially looks, it's not unique because you can choose any value you want for x1 and y1. Of course, once you expand it, you realize no matter which point you take, it's the same equation. Maybe a few questions here. What's the y-intercept here? That's pretty easy, right? Y-intercept is when x is 0. So the y value is 47 over 11. We got that. What's the x-intercept? X-intercept is where we intercept the x-axis. So that's when y is 0. So I need to replace y by 0. So in that case, I need to work it a little bit. So when y equals 0, 0 is minus 2 over 11x plus 47 over 11. I can get rid of the division by 11 by just multiplying by 11 on both sides. And solving for x, what does that give me? 2x is 47, so x is 47 half. That's my x-intercept.